Hi everyone, welcome back to another exciting video of the PICO VR development series with Unreal Engine. In today's video, we'll show you how to increase the sense of presence of your VR application by animating the virtual controller buttons. And we'll explore how to get the current battery power level of your physical controllers and display it over the virtual ones. So let's get started. By the end of this video, you'll have a solid understanding of how to animate every part of a PICO 4 virtual controller and how to get information about the current battery level of PICO controllers. So grab your headset and follow along. In this tutorial, we'll start by showing you how to link user input to virtual controllers to make the controller buttons and thumbsticks animate. We'll also explore the PICO API that allows you to get the current power level of your PICO controllers. And we'll use that information to set up dynamic materials on the virtual controllers, which will modify their appearance so the current battery level is displayed on them as a progress bar. We'll provide instructions for both Unreal Engine 4.27 as well as Unreal 5.1. In the previous video, we added virtual PICO 4 controllers in our application, but you probably noticed that as you press the buttons on the physical controllers, the virtual buttons don't move or animate. However, the PICO XR plugin comes with animations for the PICO 4 virtual controllers, so we're going to show you how to make a small change to the blueprint of VR Pawn, enabling controller buttons to animate according to user input. Open the VR Pawn blueprint and select the left controller mesh component. In the Details panel, make sure Animation Mode is set to Use Animation Blueprint, and then for the Anim class, search for the PICO 4 Left Controller Animation Blueprint. Do the same for the right controller and select the equivalent Animation Blueprint class. This change will make the controllers animate according to the behavior defined in their animation blueprints. Go ahead, select the left controller mesh, and then open the animation blueprint we just assigned to that component. Then click on the animation graph and click on the New State Machine. You'll notice that this state machine is already set up to work properly, and if we go to the animation preview editor and change the values of the variables here, you should see that the buttons animate properly. So why exactly is this not working in the VR template scene? If we go back to the event graph, you'll notice that here the event blueprint update animation is expecting for the player pawn to always be the blueprint PICO XR pawn. This is actually a pawn that exists only inside the PICO XR plugin. However, the VR template scene is not using that pawn, and instead it's using its own VR pawn. That's exactly why these variables here are not getting updated properly whenever the player presses the controller buttons. To fix this issue and make the animations work with the VR pawn, all we need to do is to make sure that the variables of the animation blueprint are updated according to the user input through the VR pawn. The first thing we need to do is go to Begin Play of the VR pawn and actually cast the animation instances for the controller mesh left and controller mesh right animation blueprints. So create a new sequence and then get the controller mesh left variable. From that, search get anim instance to get the animation instance. And the next thing you need to do is actually downcast that variable to the same blueprint we assigned to controller mesh left previously. Promote that variable so that it becomes a variable of the VR pawn. Rename it to left controller ABP. Now repeat exactly the same procedure for the right controller mesh, but make sure that this time you downcast to the right skeleton animation blueprint and promote to a new variable, renaming it to right controller ABP. Now we will use the input events and connect them so that they automatically update the values of the animation blueprint instance variables. Go ahead and do that for all the available animation blueprint variables. I'm going to fast forward this video, but feel free to pause to actually see the changes. If you now run the application, the controller buttons should animate the moment you press them, and the virtual thumbstick is also going to move the moment you move the physical thumbstick. Before we test the app, let's make one more change. We're going to make sure that the small progress bar line shown at the bottom of the controller model updates according to the current power level of the controllers. If you select the controller mesh and then open the skeletal mesh, you'll notice that it has two materials. Isolating the second material is going to show you the progress bar. And by opening the material, you're going to see that it has a texture parameter that can actually change according to the current power level. So what we need to do is to actually create dynamic material instances that will allow us to dynamically change the texture parameter used depending on the current controller battery level. Let's go to the construction script of the VR pawn to do that. Go ahead and create a sequence, and then create dynamic material instance. For the parent material, search for the power and specifically material instance PICO 4 power. Promote this to a variable and rename it to material power left. Then set the material of the controller mesh left to use the newly created material. Make sure that you pick element index 1, which is the second material as we showed. Then repeat exactly the same process, but this time for the right controller. Create two new integer variables called left controller current power level and right controller current power level, which will be used to hold the current power level for each controller. Also, create one more variable, an array of textures, which will hold all the possible 5 texture parameters we may need to use in the material. Rename it to battery level textures. Go ahead and add the 5 possible different power textures, starting from power 05 all the way to power 01. Next, go back to the event begin play of VR pawn to create a timer that is going to run every 1 second in a loop. From this event, we want to check for each controller the battery power level it has, and according to it, update the dynamic material instance parameter of the texture that needs to be added to it. So, create a new event that is going to run every 1 second, and then for each controller, use the API provided by the PICO XR plugin by using the function pxr getControllerPower. This function takes as an input the left or the right hand controller and returns whether it got a valid measurement through the return value and an integer called power, which is actually a value from 1 to 5, 5 being the maximum power the controller can have. So we're going to check, first of all, if the cast version of the left controller current power level is different than the latest measurement, and if it is, we're going to update the saved variable. Make sure that you decrement by 1 the power level, since, as I said, the possible values are from 1 to 5. So we want to make sure that we get the 0th element of the array if the battery power level is equal to 1. After we get the battery level texture that is required, we can then use the stored material power left, which is the dynamic material instance we created, and then use set texture parameter value by updating specifically the texture parameter. Pass that value and then connect everything together. Next, repeat exactly the same steps, but this time for the right controller, making sure that in the PICO API you pass the right hand as an input, and also making sure you use the right controller current power level variable as well as the right material instance we created earlier. After packaging an application and running it on PICO 4, you can see that now the controller buttons do animate, and as you press down all those buttons, you can see them reacting to your input. This way we actually increase the sense of presence as well in our application. At the same time, you can see that the progress bar is updating according to the current power level. If you're using Unreal Engine 5 instead of 4.27, then you can follow the exact same steps to achieve the same behavior. But since Unreal Engine 5 mainly uses the enhanced input system, you should create a set of new input actions and connect them to update the variables of the animation block. Go ahead and create a new folder under Input, Actions, and rename it to Controllers. Now create a set of input actions for each button of the controller, as we did previously, by making sure Consume Input is set to False and Value Type is set to Bool. Feel free to slow down or pause the video at any point to make sure you get it right. Do the same for the thumbstick X and Y values, but set the value type there to 1D axis since it's a float value. After creating all of the input actions, go back and create a new input mapping context and rename it to IMC controllers. For this mapping context to be activated within our VR scene, we need to actually add it within the VR template's player mappable input config file. So go ahead and add a new entry under the context list with the newly created IMC controllers input mapping context. Now open the input mapping context of the controllers and go ahead and add in the mappings all the input actions we created and make sure that they are connected to the right input bindings for the PICO controllers. Go ahead and slow down this video if you want to see exactly the changes we made. Go back to the event begin play of VRPon and replace the IMC hands mapping context with the one we just created for the controllers. The last thing you need to do is connect all those input action events to make sure they are updating the animation blueprint variables to make our controller move. If you enjoyed this video, make sure to give it a thumbs up and subscribe to our channel for more exciting tutorials. And follow us on Twitter to get the latest updates about the PICO SDK. Thanks for watching.